Hello everyone and welcome to Thinking with Mathematical Models 3.3. Learning target today is we want to be able to write inverse equations and use them to solve problems. So remember, our inverse equations are going to take the format of y equals k, our constant, divided by x, or format of x times y equals our constant. So our ACEs today be on page 72, beginning on page 72, numbers 9, 31 through 36. 3.3, we're planning a field trip and trying to find the individual cost for each person on that field trip. So it tells us the science teachers at Everett Middle School want to take their 8th graders on a field trip to a nature center. It costs $750 to rent the center facilities. Okay. So the total cost, no matter how many people go, no matter what, is going to be $750. And it tells us that the school budget does not provide funds to rent the center, so students have to pay a fee for this trip. Now, there's 250 total students. If all of them go, then it will cost $3 per student. So $3 times 250 people equals $750. But the teachers know that it's unlikely that all of the students will go or that all will be in attendance that day. So they want to find a cost per student for any number of students, no matter how many wind up going. So again, we want to be thinking about our equation set up as y equals our constant. What's our constant here? Well, our constant is no matter how many people go, it's going to be $750. So our constant is 750. Y is going to be your cost per student, and X is going to be the number of students that go. As we get into the problem here, this is on page 66, and these are the parts I want you to do. Part A, numbers 1 and 3, and then all of B and all of C. It says to identify the relationship between the number of students and the cost, begin with sample calculations, then look for a pattern in your results. So it wants us to do this table and find the cost per student. Remember, we're still working with that y equals k divided by x. Well, if k is 750, this is your x. Okay, all of these numbers are your x, and you're trying to find y. So if we have 25 students go, we are going to have an equation that has us y equals 750 divided by 25. Okay, so if only 25 students go, it's going to be $30 per student. Okay, so pretty expensive if we don't have very many students going. So instead of $3, if 250 students go, it's going to be $30 if only 25 students go. So, so our answer here would be 30, and then I want you to go ahead and complete the rest of the table. Then from there, write the equation relating cost per student C to number of students N, which you can kind of steal from here. Okay, but I want it with the variables in and your one constant. Part B, find the change in the cost per student as the number of students increase in the following ways: from 10 to 20, from 100 to 110, and from 200 to 210. And it asks if the function relating the number of students is linear, and be able to explain why or why not. And do equal increases in numbers of students cause equal decreases in the cost per student? Okay, so is every one student increases, is there an equal decrease in the cost per student? Finally, C, how will doubling the number of students change the cost per student? Okay, if we went from 10 to 20, or if we went from 50 to 100, or 100 to 200, so how will doubling the number of students change the cost per student? And test your ideas about that question. Find answers to these related questions. Find the change in per student cost, doubling from 20 to 40, 40 to 80, 80 to 160. Describe any patterns you see. And how does our equation from question A help to explain the effect of doubling the number of students? So tie it all together there. All right, that's it for that. Again, our ACEs are numbers 9 and 31 through 36. Hope this is helpful, and I look forward to answering your questions and helping you with your stuck points in class.